Hello everyone. In this video I will discuss the two methods that we are going to use to solve some circuits, namely Thevenin and Norton's. So these two methods state that for any circuit there is an equivalent one that we can model as a single source and a single resistor. In Thevenin we use a voltage source, and in Norton's we use a current source. Let's try to solve the first task using Thevenin methods. What we do in this method, we see how the circuit behaves in two different states. The first state is when we have open circuit from the point of view of the rest of the circuit that we do not analyze. Okay, so we have some virtual resistor right here, which depicts the rest of the circuit, and we try to model this part with a single resistor and a single voltage source. So first, what we are doing is we are checking what is the voltage here in case of open circuit. So what we know is that we have a 10 volt source, two 5 ohm resistors, and one 10 ohm resistor. In case of open circuit, there is no current flowing in this branch or in this one, because of course the circuit is not closed here, so current has no way to flow. So in this case we can redraw this circuit like this. So we have this 5 ohm resistor, I moved it right here, and the second one, and what we are doing is we are checking what is the voltage right here. Okay, so we ended up with two 5 ohm resistors, so this is 10 volts. So we have the first resistor and the second one, and what you can see here is that they divide voltage in half, okay, because we have a classical voltage divisor based on two resistors. They are equal in resistance, so in this voltage is half of the input voltage, so we can formally write it down as U over 10 is equal to 5 by sum of these two resistors. Okay, so this is the voltage on the first resistor, sorry, this is the resistance of the first resistor, and this is the sum of these two. So from this we know that U over 10 is equal to 5 tenths, so U is equal to 5 volts. Okay, so now we calculated what is the voltage in case of open current, in case of open circuit right here. The second thing we are gonna do is we're gonna try to calculate the resistance in case of removing the voltage source. So let's redraw this circuit without the voltage source. So we have short circuit right here, 5 ohm resistor, 5 ohm resistor, and 10 ohm resistor, and we are calculating what is the equivalent resistance of this circuit. Okay, so we are doing the things that we already did in previous classes. This is very simple circuit, so I'm sure there will be no problems with that. What we can say is that we have these two connected in parallel. To make it more obvious, we could move this resistor right here. Okay, so we have this one and this one in parallel, and they are equal in resistance. So we know that two resistors connected in parallel with equal resistance, the equivalent resistance is half of one of them, so 2.5 ohm. So this leads us to 2.5 ohm resistor and 10 ohm resistor, and these two are connected in series, which gives us 12.5 ohm resistor. Okay, so this is the equivalent resistance of this circuit. So what we did, we made an assumption that all voltage sources are changed to short circuit. Okay, so we just you put wire instead of voltage source. If we would have more voltage sources, of course, all of them would change to the wire. Okay, so now we have calculated voltage and the resistance, and then we can create a replacement circuit for the first one that we had. We can replace this one with the Thevenin circuit. So this circuit looks simply like this. We have single source and a single resistor, and its value is of course the one that we calculated. So we have 5 volts right here and 12.5 ohms resistor. Okay, so this circuit is equivalent to this one, and we did that using Thevenin's method.